Hey guys, wanted to put together a real quick video today just to show you guys and remind you all how we reduce our fractions. So the difference between our two types of fractions and how we reduce each one, since we reduce them a little bit differently. So over on the left you'll see that we have proper fractions. And remember, the proper fraction is called a proper fraction because the number on top, so our 10 up there, is much smaller than the number on the bottom, our 12 down there at the bottom. So that's why it's considered proper. Down here below that you see the 5 and 10/12 is also considered a proper fraction. It's a mixed fraction, meaning that we have a whole number, so that 5, a numerator and a denominator, the 10 and the 12. So very similar to what we have at the top here, except we've got this 5 in the front of it, and that's what makes it a mixed fraction. But it's also ranked in our proper fractions category simply because still the numerator, the 10, is larger than that 12, the denominator. So we're going to reduce both of these fractions the exact same way. Both of those are how we're going to see how we reduce those proper fractions. And then we'll take a look at the improper here in just a second. But with proper fractions, what I want to do is I want to look at both that top number and the bottom number. We need to think of factors of those two numbers, meaning what can I divide both 10 and 12 by? So thinking about all the numbers I can divide 10 by, I can divide 10 by 10, and it would give me 1. 10 divided by 10 is 1. I can also divide 10 by 5, because 10 divided by 5 would give me 2. And I can also divide 10 by 2, because 10 divided by 2 would then give me 5. So I'm looking at numbers I can divide this 10 by that would give me a whole number as the result. If I divided 10 by like 9 or 8 or something like that, it would give me a decimal, and I don't want a decimal when I'm reducing. So those are the only three options as far as what I could divide that upper number by, that 10. Down at the bottom though, if I can divide that bottom number by the same thing, then that's what we do. We're going to go ahead and reduce it that way by dividing them by the same thing. Now, asking myself about that 12, can I divide 12 by 10? Well, if I take 12 divided by 10, it's going to give me a decimal, like 1.1 or something, or 1.2. Hang on, 12 divided by 10, yeah, gives me 1.2. So I can't use that. So we're going to eliminate that. Can I divide 12 by 5? Well, 12 divided by 5 gives me 2.4. So I can't use that because it gives me a decimal. But can I divide 12 by 2? Yes. 12 divided by 2 gives me 6. So because I can divide both 10 and 12 by 2, that's what I'm going to use. So I'm going to go ahead and eliminate all these other options here. We're going to divide both of these by 2. And that's what I mean by dividing them by the same thing. Remember always, anytime you change that top number, you have to change the bottom number the same way. So if I divide this top number by 2, I have to do the exact same thing down at the bottom. And that's how we're going to reduce those proper fractions. Always remember, if I can divide them both by the same thing, do so. At the end of a problem, if you can divide your fraction further, do it. So 10 divided by 2 gives me 5, and then 12 divided by 2 gives me 6. Now looking at that 5 and 6, because I cannot divide them both by the same thing, that is my simplified answer. 5, yes, can be divided by 5 to make it 1, but 6 divided by 5 would give me a decimal, so because of that, I'm not going to divide it any further. Only when I can divide them both by the same thing. Same thing's going to happen down there with the 5 and 10/12. In this case, not any different at all. The only difference is that 5 simply just stays in front. So the 5 is going to stay in front. We saw from our previous example that 10/12, since I can divide them both by 2, that reduced to 5/6. So in this mixed fraction down here, my answer is going to be 5 and 5/6 instead. That whole number just stays the same. If it was 6 and 10/12, it would reduce to 6 and 5/6. That whole number just doesn't change. So that's how we reduce those proper fractions. Proper fractions are going to reduce by dividing your numerator and your denominator by the exact same thing. So, you know, if I were to take another look at some of these, you know, more of these fractions here, let's just get these out of the way and let's look at some other, I'm going to go back to that. I'm going to leave this 12/10 over here. But let's look at some other proper fractions just for example purposes. Let's say we have, I don't know, let's say 5/20. So 5/20. Looking at both 5 and 20, think of the things that I can divide 5 by. And if ever in doubt, just start really small. Can I divide 5 by 2? If you check that in your calculator, 5 divided by 2 gives me 2.5. Again, don't want a decimal. 5 divided by 3 gives me 1.6. 5 divided by 4 gives me 1.25. But 5 divided by 5, we know anything divided by itself will give me 1. So yes, I can divide that top number by 5, but I'm only going to do this if I can also divide that bottom number by 5. And 20 divided by 5 does give me a whole number of 4, so because of that, we can reduce this fraction. It reduces to 1/4. So that's just another example of those proper fractions. Again, when the top number is smaller, I need to look at my top and my bottom number to see if they can both be divided by the same thing. Now looking at the other side here, looking at these improper fractions, again, opposite of those proper, top number, in this case, is going to be larger than the bottom number. That's what you're seeing here. 12 is bigger than 10. So we're going to reduce these a little bit differently, because again, now what we're looking at is, again, with fractions representing a part to total relationship, part over total, this is showing that I have 12 out of a total of 10. So in that case, what that means is I'm going to have more than one whole object here. Again, I always use pizzas as my way of representing fractions. So this means that I'm going to have more than one pizza, because that pizza is cut into 10 slices, as that bottom number shows there. But because I have 12 out of 10 slices, it means I'm probably going to I'm looking at more than one pizza here, because I have 12 slices. So what happens with these, a quick way to reduce these improper fractions, is I'm going to look at this as long division for just a brief second, as top divided by bottom. So 12 divided by 10. If you put 12 divided by 10 into your calculator, again, 12 divided by 10 is going to give us that decimal of 1.2. So we don't want it to reduce to a decimal. We're going to see how to do that later on. What I want is I want to reduce this to a mixed fraction. So I'm going to write this out, and I'll show you what I mean by that. So 12 divided by 10, when you do that in your calculator, like I said, you get 1.2, which means that 10 is going to go in one whole time. So what I do is I take this 1 times 10 here, and I'm going to write that answer just underneath that 12. Because now what I want to do is I'm going to subtract 12 minus 10 to get a remainder. So I get a remainder of 2. So what I do with that remainder is, what happens is that's my fraction now. My answer up here at the top, this 1, becomes the whole number of my fraction. So it's going to be 1 and something. Like a second ago we saw that previous mixed fraction was 5 and 5/6. That's what's happening to this. Improper fractions usually turn into mixed fractions or just a whole number. So my 1 is my whole number here. My remainder, so this 2 down here at the bottom, becomes the numerator of my fraction. And then the 10, which was originally my denominator, is going to stay my denominator. So my fraction is currently 1 2/10. So that's how we reduce those improper fractions. This happens to be a great example to show that sometimes when we reduce those improper fractions, sometimes I can go a little bit further, because again, remember how we reduce those proper mixed fractions? If the top and the bottom number in my numerator here, if I can divide them both by the same thing, I want to continue to do so. So this one's actually going to reduce a second time, because 2 and 10, I can divide both of those by 2. Remember, all even numbers can always be divided by 2, so that definitely gives us a starting point there. So again, when we reduce those mixed fractions, my 1 stays the same. 2 divided by 2 at the top is going to give me 1, and 10 divided by 2 gives me 5. So my fraction answer here is 1 1/5. So that 12/10, when the top number was bigger than the bottom number, we reduced it by division. Let's take a look at another example then with our improper fractions. Let's say we have, I don't know, how about 15 over, let's say 15 over 2. How about that? So 15 halves. Again, that top number is a lot bigger than that bottom number, so that's what makes it an improper fraction. So again, we're going to divide it by long division. So 15 divided by 2. Again, we're remembering it as top divided by bottom when that top number is bigger. If I do that in my calculator is going to give me 7.5. Again, I don't want that decimal, but that does tell me that 2 goes into 15 7 whole times. Again, to get that remainder, what I do is I take 7 times 2 and write that just underneath here. That 7 times 2 gives me 14. What I do is I subtract these two in order to get my remainder, and 15 minus 14 is 1. So writing this as a fraction, again, my answer was 7. That becomes my whole number. My remainder, which was down here at the bottom, that 1, becomes the numerator of my fraction. And the denominator, which was originally 2, stays the denominator of my fraction. That 1 over 2 cannot be reduced any further, so this is my complete answer, 7 1/2. So that's how we reduce those mixed fractions. And remember, those improper fractions. And remember, like I said, they turn into mixed fractions, but every once in a while you may find an improper fraction that just reduces to a whole number. So for instance, if that wasn't 15 over 2, let's say it was 15 over 3. So once again, we still have an improper fraction, so because of that, I'm still going to take 15 divided by 3. But when you look at that in your calculator, you don't get a decimal. 15 divided by 3 just gives me an even 5. So if we were to check, 5 times 3 is 15, so again, I get no remainder. So because of that, I just have no fraction. My answer is simply just 5 by itself. So that's another way that we can remember those improper fractions. Every once in a while, they just reduce to a whole number. Or another example would be one that we saw in class, would be that if we had, say, 15 over 15, well, 15 divided by 15 is 1. So anything over itself is always going to reduce to just 1. So that's our reducing. I hope that helped, guys. If you guys have any questions, you all know you can call me or email me and let me know. I'd be glad to meet you for some tutoring, or I can send you another video if you need to see more examples. Just let me know.